Imagine it's Friday, 4 p.m. You've just deployed the new order to delivery microservice flow. You used a nice, clean set of REST calls. Service A calls Service B, B calls C. It's elegant, it's decoupled. You go home, open a beer, and feel like a cloud-native god. Then at 2 a.m. the pager goes off. A customer bought a 2000 espresso machine. Service A, the orders, created the record. Service B, the payments, successfully charged the credit card. But Service C, the inventory, was having a moment because someone decided to run a backup during peak hours. The inventory update failed. The result, the customer has no expression machine, you have their 2000 used, and your database in Service A thinks everything is fine. You spend the next 4 hours manually running SQL updates across the 3 different production databases, squinting at logs like they are the matrix, trying to figure out who to refund and what to delete. This is the distributed transaction nightmare. We killed the monolith, and in our excitement we buried AC transaction in the same grave. We traded one big, manageable fire for 1,000 tiny invisible ones. Welcome to the Saga Pattern. It's the industry's way of admitting that distributed systems are a mess, and the eventual consistency is just a fancy term for it will be right, eventually, hopefully, maybe. My name is Sergio, and I spent way too much time thinking about why we build systems that are destined to fail. This is the second video in our Microservices Architecture Patterns playlist. If you missed the first one, you're already behind on your technical debt. If you ever looked at a distributed stack trace and felt your soul will leave your body, hit subscribe. We're digging through the architectural trenches together. Before we look at the code, let's address the psychological denial we live in as developers. We tell ourselves these lies to avoid the complexity of sagas. The network is reliable. It's not, it's a series of tubes held together with duct tape and prayers. I will just use a two-phase commit. No, you won't. This isn't 1998, and your modern NoSQL database doesn't support it. Even if it did, the latency wouldn't turn your high-performance API into a carrier pigeon service. I will just add a transactional annotation. That worked great on one database. Too bad, your database is scattered across 3 AWS regions and the legacy servers in someone's basement. I will fix data inconsistencies with a cron job on Monday. This is the developer equivalent of I will start my diet tomorrow. Monday comes, the cron job fails, and now we have 2 problems. This developer believes in the goodness of humanity and the stability of the internet. They write code that assumes everything works on the first try. The reality check. If inventory client reserves throws a 500, the payment is already gone, the order record is saved, the customer is calling support. This code isn't a service, it's a liability. This developer discovered design patterns last week and decided to use all of them. They've added 5 layers of abstraction, a custom event bus that only they understand, and so many interfaces that finding the actual logic is like a game of Where is Waldo. The reality check. They've built a generic Saga framework before they even solved the business problem. It's hard to test, impossible to debug, and the first time a network timeout happens, the state machine gets stuck in a pending compensation final retry v2 state forever. We're going to build a state machine-based Saga. We aren't going to use magic. We are going to use compensating transactions and a clear pivot point. First, we need to track where we are. A Saga is just a long-running conversation. If you don't write down what was said, you're going to forget. In Saga, we have compensatable, pivot, and retryable transactions. Compensatable can be undone, like unreserved inventory. Pivot, the point of no return, usually the payment. Once the payment is settled, we must finish. Retryable, transactions after the pivot that cannot fail permanently, like shipping. If they fail, we retry until they succeed. If the pivot, the payment, fails, we have to undo everything before it. If something fails after the pivot, we don't undo, we retry. Sagas are ACD, not ACID. We lost the isolation. If another process looks at our inventory while the Saga is running, they might see dirty data. To fix this, we use a semantic lock. We don't just reserve the item, we mark it as pending Saga. Why do we struggle with this? Because of the resume-driven development. Implementing a proper Saga with AWS step functions or Spring State Machine feels heavy. It's not agile. We choose the easy way, the nested REST calls. We do this because we want to ship features today and let the maintenance version of us deal with the data corruption 6 months from now. We also suffer from the cargo cult programming. We see Google or Netflix using microservices, so we do it too. But Google has 1,000 engineers to build their infrastructure for Sagas. You have a Jira ticket and a deadline for Tuesday. When you move to microservices without a Saga strategy, you aren't building a distributed system. You're building a distributed node. I can already hear the comments section. Well, actually, Sergio, why not just use an event-driven choreography Saga instead of an orchestrator? It's more decoupled. Sure, if you enjoyed not knowing what the hell is happening in your system, in choreography, each service knows what to do next. It sounds great until you have to debug flow that spans 6 services and realize you have no central place to see the state. You're essentially playing telephone with €100 bills. For 90% of business cases, a central orchestrator, like a state machine, is better because it's observable. You can actually point at a dashboard and see where the order died. But Sergio, what about the overhead of persisting the Saga state? What's more expensive? A few milliseconds of DB write for the state machine, or your lead developer spending 10 hours on a Saturday morning manually reconciling bank statements with database records? Do the math. If you are going to implement Sagas tomorrow, do this. Identify your pivot point. Usually, this is the action that is hardest to undo. The money. Define your compensations. If you can't undo an action, it must happen after the pivot and it must be retriable. Don't roll your own framework. Use AWS step functions, temporal, or Spring State Machine. These tools handle the what if the orchestration itself crashes problem, which, trust me, you don't want to solve yourself. Embrace idempotency. Every service in a Saga must be able to receive the same command 5 times and only execute it once. If your refund endpoint isn't idempotent, you're going to have a very bad time. Distributed systems are hard because we pretend they are just monolith with network roles. They aren't. They are chaotic environments where everything can go wrong. Will go wrong, usually while you're trying to sleep. The Saga pattern isn't about making things perfect. It's about making the failures manageable. It's about having a plan for when the world burns down. Now go delete the nested try-catch block and actually design your failure path. And see you in the next video. Bye!